Hello friends, welcome back. Ever wondered how to design a clean, efficient and scalable APIs? In this episode, we will deep dive into the microservices, HTTP status codes and build the CRUD operations with clean architecture. So let's code smarter, not harder. Come, let's get started. This video is a part of the Smart Certify video series. We were building the online certification platform application, and this is episode 12, and we will be covering the complete CRUD operations for 3 different controllers, and we will have a lot of stuff added. We will be using the clean architecture principle to design the complete web APIs. We'll be using the Fluent validations and much more stuff. So come, let's dive into the concepts. So what you can expect from this video is you'll be able to build the CRUD operation for 3 controllers using the clean architecture principle. So these are the 3 controllers: choice controller, which will have these many endpoints, and the course controllers and the quotient controllers. But if you watch this carefully, you'll be able to see 5 major types of HTTP that we'll be using. So get, post, put, delete and patch. Alright, so all of this usage we will do from the scratch, and this is what you can expect from this video. So before we put our hands on the code, let's understand some basic concepts of these web APIs, microservice and other stuff, so that it will be helpful for you when you build the application. So just to get started, we will be exploring what is web API and what is web API versus microservices and what are the HTTP status codes. So web API. A web API is a set of protocols and tools for building the software application. It allows different software systems to communicate with each other over the web. Alright, so this is what the definition is, but it's good to understand the purpose. So the primary purpose is to enable the interaction between 2 disparate systems. Okay, for example, a client application and a backend application that interacts. Now, this is still theory, right? So let's understand in a realistic. So in this series, we will be building this Angular application. This is the front end and there's a back end, right? So disparate system means this is one system and the other system is the backend system. They both don't know each other. Okay. So for example, a web API is nothing but this front end system is talking to the backend system. And if you see when we navigate, this is a web API which is invoked, and the web API is returning some response, and that it is using and able to show up this kind of a nice UI. So if you go to different place, it is calling a different endpoint and we are getting some different response. Based on the response that we get, the UI is able to show some information, right? So this is what called disparate system, which is having communication between 2 systems and the data are exchanged. Okay, now here if you closely look at this API, we are referring to web API, right? So let's take any web API. So if you go here, like I said, one of the important, so if you go to this endpoint, you can see this is the request URL, and this is of type a get method, and it is returning a status code. So what and all we have in this concept, we have a URL, like a point where we are it's like a unique point to which it is going to respond to you. Okay, and what type of point it is, like get endpoint or different endpoints. Get means retrieving some information, that's what called get, and it is returning a status code which browser will understand, the client will understand, and one of the status code is 200 OK. You see this, it's a green color, 200 OK. We'll talk about it. So these 3 are the important parts, and if you look at this URL, after this API, the first one is the controller name followed by the action name. If there is no action name, basically it's a default get. We'll explore that, but these are the parts. The reason why I'm showing this is, see, this is what the reason. So the whole web API consists of this URL, and you can split that URL into a controller method and where it is pointing. And not only that, it also shows what type of get endpoints, like what type of HTTP methods you are using. One of the methods is the HTTP get. Okay. Similarly, we have post, put, delete, patch. We will explore those things as we progress. Okay. Now, request and response, right? So you made a request, it sent a response in a JSON format, which is what client used to, and then format the UI nicely. Okay. So that is what this is web API components means. So what is microservice then? Microservice means it's basically a small independent service that does one thing well, meaning not too many things, right? It's a part of a larger architecture where multiple microservices work together to form a complete system. So let's take the same example of the web application. If you look at this web application, okay, you have something related to exams, okay? That's why any of these things, if you look at this one, it starts with exam, okay? That's one service. Similarly, if you look at this course is completely doing some course related stuff, that is one service, okay? So basically, in order to complete this whole application, there will be different services, okay? So microservice means nothing but a small application. So in other words, the whatever we are building, right? So in terms of our usage, basically we have built all of these three controllers into one application because this is just the learning phase. But in a realistic view, if this has to be converted into microservices, the choices alone will be one microservice, courses alone will be one microservice, questions alone will be one microservice, where it does lot of questions later stuff, okay? For example, so look at this, exams alone will be microservice, all the exams later stuff will be handled, courses will be handled, choices will be handled, all right? So many things, right? So whenever in a real world application, like you consider Amazon or something, like where orders, how many people will order, how many people will browse the product? Browsing the product is more than number of people ordering it. Similarly, address, how many people will keep changing their address? So if you consider if you consider Amazon website, addresses will be one services, product will be one services, reporting will be one services, order is one services. They split this into different microservices. Reason because when they split a bigger application into multiple microservices, they can scale up. Scale up means on the demand basis, only those microservices can be deployed into multiple places so that the load can be balanced. Okay, so that's the reason why microservice is an architecture principle. It is not related to any web application. It is not related to any web API or something. It's basically an architectural pattern. Okay, now let's get back. So a microservice is a small independent service that does one thing well, like I said, reporting, order, address, products. It is part of a larger architecture, meaning all together, right? So Amazon cannot operate without any of these things. It has to have address service, it has to have product service, order service, so and so service. All of the service together is what application is. But behind the scene, each one is called one microservices. Okay, that's only completely will form one application. Now let's go back. So whatever I explained is what is in the scope. So we have all of these examples we just explored. Now what are HTTP status codes? Okay, so don't worry about these slides, I will give you all of these materials, but let's concentrate this. What are HTTP status codes? HTTP status codes are standard codes written by the web server to indicate the result of a client request. Okay, so they are grouped into 5 categories. So let's understand this. So if you look at this, we have 5 different things. So get, post, put, delete, patch. Let me explain you what these things does. If a client is calling this one, which is a get endpoint, okay, it is asking for some data. It might be sending some unique ID and asking for a particular resource, or it is asking for a bunch of data. Okay, now let's say you're filling a form. You are only providing information, right? At that point of time, post is the one which we have to use, meaning a new record that is getting created behind the database, like behind the table or whatever it is, right? A new information is being recorded newly. That's when you use HTTP post. Okay, so in this example, right, I wanted to create a new course, then this is what I will be using it. In Amazon example, first time when you go and enter your address as a shipping address, you're creating a resource. You will use HTTP post. Okay, now when does this put will come? Let's say same Amazon example. You created the address, but you know that there's something wrong in the address. You wanted to update. Maybe door number is wrong, address line is wrong, something is wrong, right? More than one field is wrong. That's when you use put. So put is to update. Delete, as it goes by name, you wanted to delete what you saved. You wanted to completely remove it from the system. You use delete. In order to use delete, you just need to uniquely identify the resource by some ID, then you delete it. Patch. Let's say address example. You wrote every single line of the address is correct except the zip code. Only the zip code you need to update. It means out of the whole bunch of fields, only one field you're updating. So for that kind of a situation, you generally go for the patch. Patch means you're like patching, right? If there's a road, there's a small hole in the road, what they will do? They put the road or they put a patch on the hole. They put a patch on the hole, right? We say it's patching. That's what called patching. That's what called patch. Okay. Now you understood a realistic example. Now let's go back to this HTTP status code. So what it meant is each of these services, each of these different endpoints, each of these different HTTP endpoints returns a particular status code that is understandable and defined for the front end whoever is calling. For example, if you're calling something like this, okay, so let's take an example. It is asking for ID. It is telling you, hey, I wanted to get a course whose ID is 78. Execute. I got a value, which means it is there. I'm asking return a course detail that is specifically called 78. Course ID 78, I returned it. What if I'm asking like this? It's returning a 404. The first one returned 200, okay. The second one is returning 404. Which means such ID does not exist. Such course ID does not exist. Do I have anything like 3? No, does not exist. Can I have something like this? Do exist. So based on the code that is returned, the caller will know what's happening. The UI will know. Okay, the browser will know. Okay, 200 means okay, data is there, it returned. 404 means data is not there. It's telling you, hey, whatever you sent, I don't have such data. Like for example, right, if you're studying in a school or college or like in an employee, you have employee ID. If you're studying in college, you have a student ID, right? Somebody is coming from a particular place and they're asking, hey, send me the student. Principal is calling a student ID 110. There is no such ID exist, so we cannot send any student. They have not given a student name. So every single status code represents a meaning, and that meaning is very important. If you send the correct status code, the client knows, the caller knows what to do. Okay. So now let's take a look at the different status code, because all of this thing we are going to use it in our development. So let's go. That 5 categories starts with 1, 2, 3, 4, 5. 1 is just information, you don't need to do anything. I have not seen 1 easily. 2 is all like success. You requested something, processed and got your result. That's what called 2. 2 can be 200, 202, 204, 202, 204, all of those things we will see in the next slide. But anything that starts with 200, 2 is successful. 300 means something is changed in the requested URL. So they're saying you called me, yeah, like, it's like this, right? Someone is asking you to go to point A. After you go to point A, there is somebody who is telling you, hey, whoever told you to come to point A, that is not there anymore. We move to point C. Please go to point C. That's what called redirection. The server will realize that there was such URL access, but now it's not there. Go to this so and so place. The client will know what to do. The browser will know what to do. Similarly, 4. Client error. Anything that starts with 4 is client error. What does it mean client error is? Let's say you are client, I'm server. You're asking me something, but you asked me something incorrectly. So because you asked incorrectly, so let's take an example, right? So you're client, I'm server. You asked me incorrectly something. Like say for example, you asked me a chocolate, But you didn't tell me what chocolate it is, what type of chocolate it is, white chocolate, milk chocolate, dark chocolate. You didn't tell me. So I return a status to you saying, hey, 400, bad request. You told me chocolate, you didn't tell me what kind of chocolate. I cannot give you, without you telling me, I cannot give you all of the chocolate to you. You have to tell me what you want. Good. Client knows. Okay, fine, I did a mistake. Give me lollipop. Fine, request came with the specific stuff. Lollipop, I do have, give it to you. I don't have lollipop, I give you 404. Mean, you asked me lollipop, I do not have lollipop. So anything related to 400 is a client error which they can rectify. Let's talk this in a realistic view, right? So let's say you're trying to add an address. Zip code is important. Okay? You didn't provide a zip code and you're trying to make a HTTP post. I validated. I said, hey, you did not give me a zip code. I cannot deliver anything to you properly. I send a bad request saying, hey, zip code is missing. Client knows that you're missing and they recorrect and they can refire the request, resend the request. There, all of these things is possible. Okay. So in short, in interview, if somebody asks you what is client error, what is 400 and all, it's basically you can rectify any 400 related things. Client can rectify and re-request, resend the request. That's important. 500, God knows, everything is bad at the server side. You all gave me something correct. I couldn't process it. Something blowed up from my side. Same thing. You sent me address details. Database was down. I'm not able to save it. Blowed up. I was able to send you a 500 internal error. I don't tell you what error it is, but it is an internal error which you cannot do anything. You can just report to the customer support. Okay, so now you understood all the difference, right? So these are the different status codes and its meaning. You look at this, all of these meanings. See, 300 is all of these things. 400 is like bad request. So very frequently used as bad request. 401, unauthorized. Like you're not even allowed to enter. You're not even allowed to call that endpoint. Okay, and 403, you're allowed, but not this one. Maybe you do not have rights. Something like that. Okay. 404 we already discussed. 405 is like incorrectly calling a particular method. Like this, so many stuffs are there. 409 is very important. Not everybody uses it's very tricky one. Do let me know if you wanted to know what is this 409. That's a conflict. I will explain you in the next video. But so many error codes, and then 500 you can't do anything from a client perspective. It goes wrong, internal server error, gone. There is no implementation. There's bad gateway, service unavailable. Let's say service unavailable, you would have seen it. Like something, the service is not at all up. So you get this 503. Okay. If there is in between some, communication is wrong, 502 you will get it. But at any point of time, all of these things, you can't do anything. But you should know what are these status code. And when you send, you have to send a proper status code so that a robust application can be built. All right, so enough theory. Now let's put our hands on the deck and start building the application. All right, so in episode 5 we were building the basic structure of the web API. So those who are new here, go to this github.com/learnsmartcoding/. This is the the web API repository URL. So here we just have the main code, right? So main branch. So I have actually downloaded that and I have opened it. Okay, so we are going to do something here for this video, and we were also talking about DevOps. So whatever you do, you can actually push to your DevOps repository so that as we start building the CI/CD pipelines and all, it'll be easy for you to deploy to the Azure. All right. For me to share the code, I'll be using the GitHub just to share the code, but I'll be still having all of my stuff in the Azure DevOps. Okay. Now, if you look at this, I promised I'll be explaining the clean architecture as we start building the real web APIs, right? So I didn't get a chance to explain more about the clean architecture, and we're going to take a look at the clean architecture structure here, and as we build, we will explain you one by one. So we have 4 projects. One is the main project called web API, and in the application, domain, and infrastructure, right? So we don't know what is all of these things. At a high level, we know where the interfaces will go, where the repositories will go, but this is what I would like to show. First of all, what is a clean architecture? So clean architecture is basically a software design philosophy that separates the concerns of an application. This will allow us for the independent development and testing and deployment. What is the goal? If you look at the goal of this architecture, right, a lot of big companies will use this kind of an architecture, especially microservices and all. So please pay attention. The main is it's independent of the framework. Doesn't matter what framework you use. It is testable. UI is independent. Database is independent. Easy to maintain. All of those things we can do. And at a high level, this is how the clean architecture in a onion view they call it as. So just imagine this is onion, right? If you take an onion and start peeling, what will happen? The outer part only will depend on inner part, right? Like that, you keep peeling one by one layer, you go till down. So that's what they call it as onion. So what it means is at the top layer is the UI interface, user interface, and then it comes with the domain and then followed by the interface entities, and then there's the infrastructure layer. Okay, now if you look at this, whatever we have is in this application core and then infrastructure and UI. So let's take a look at the same thing in our project, and I will explain you how this looks. So we have these 4 layers, right? Presentation layer, which will contain the UI. UI means like basically if you're using MVC, it's UI. If not, it's all web APIs. Okay, that handles the user interaction like controllers and all of those stuff. Then we have something called application layer. Application layer, just imagine all of your business related logic. Okay, if a application is there will be some business logic, right? So those kind of thing, all the rules and regulations will be written in this layer. Domain layers are nothing but you have a database has a table, all the database related stuff, all the core database entities and all of those stuff will come under domain layer, nothing else will come. Okay, and then the last one is the infrastructure layer. Okay, infrastructure layer will have access to the database, meaning only from infrastructure layer you'll be able to talk to the database, not from the application layer. Only business logic will come here. Not only that, in case if our application is talking to an external API, okay, or different services, they call external services. All those integration, for example, let's be realistic. If we have to talk to Azure services like functions, then it's external call. So those kind of logics will come under the infrastructure layer. Okay, this is how the architecture will look. We have this domain, application, infrastructure, web API, and then followed by the test project. Each one has these details. Don't worry about this command and query. We might probably have a different video for CQRS pattern, but stay tuned. Except these 2 folders, everything else will be there. Okay, and then it's gonna help all of these things. Like it can maintain testability, flexibility, all of those stuff is easy here. Okay, now what we will do, let's go here. Okay, so if I expand this, like I said, this will have controllers which we are going to build here, and then application, right now nothing is there. Domain, in episode 5 we were able to bring up all of the database entities here. That is what called as domain layers, right? All has tables, database tables. And then infrastructure right now doesn't have anything except the DB context itself. So here it comes, here it becomes interesting. See, somebody keep saying like this, whoever is new to this architecture or all of this. So if I keep talking about this, whoever is new is going to get confused, right? So even so far, if you have not understood well, it's okay. Don't worry. Just pay attention to what I'm going to develop one by one, and you will have a clear idea of what goes where and how you can build. And not only that, at the end of this video I will give you some task. You do it by yourself. It's good for you. If you're really dedicated in learning and achieving your goal for your career, I honestly suggest you to do yourself few stuff that I'm going to give you as part of the series. Okay, now let's start the first one. Okay, so what we have to do is we have to build this first one is the courses. So courses means it is related to a particular table, just one table. Okay, so let's keep it simple. We're going to talk to one table and do all of this CRUD operations. So what we will generally do is you always have to come in the backend, like from back towards front, because from front to back you don't know who's the next one to call. So that's why I always prefer and suggest you always go reverse order. So first thing, what you have to do is we have to create an interface. So if you go to this application layer, here is the place where we need to create the interfaces. Okay, so as per the clean architecture, your interfaces definitions will come here. So let's create a folder called interfaces, and just to have more separations, we will also create a folder called courses. Okay, so under the courses, I wanted to define or create an interface. So right click, add, go to interface, and I'm going to create an interface called iCourse repository. So this interface is related to a repository, but still I'm creating the interface at the application layer, because as per the clean architecture, this is what you need to follow. So I'm creating this. So for good, let's convert this into public instead of an internal. The internal is a default access modifier if somebody asks you in the interview question. Okay, so the access modifier has been changed. Now we'll be using completely asynchronous pattern, but as we progress, we will also show you why it is very important and very easy compared to the synchronous. Okay, so follow along with me. Okay, so let's say I wanted to return enumerable of course. See, the good part is, as I type, it is thinking what I'm trying to do based on the namings, and it is already suggesting me what to do. So get courses. I can do a tab, which will become good, and I can also bring in namespace, control period, pull in the namespace, good. So this is a synchronous method. I can also change the name if in case I wanted to change it, right? So it suggested courses, but I'm saying get all courses. Okay, so this is a synchronous method. Okay, let's keep it simple, then we'll convert this into a asynchronous method. Okay, now for example, if this is the definition, right, we need to implement this. So I'm going to copy this course repository, go all the way through interface, like the infrastructure, right click, add new item, class, put this name without the I. Okay, because I name is the interface name. So here it is going to be a public class. Okay, so for good, interface definition is here, implementation is here, because this is repository. Now in order to implement an interface, what you do, a class that inherits an interface like iCourse repository, then this becomes what? This becomes the way we will try to implement this. Okay, so it's giving you error because right now whatever, so for example, if you go here, right, whatever is here, we have this method, whoever is this class, whoever is trying to inherit an interface has to implement those classes. It's not implemented, that's why it's giving error. So try to use the shortcuts. So let's put the error mark here, control period, it will ask you what to do. See, implement interface, it'll give you suggestions. Okay, so I'm going to choose this, it'll bring up, so it'll bring up the basic layer, basics thing. So from here we can modify, so we can say public, and then we don't need this, that's it. So public, the name of the the method, and then because we did not implement anything inside this, it is throwing not implemented exception. So we will test this. Now because this method is going to talk to the database, what do we want? We want the DB context, right? So the next thing is CTOR and enter a tab. It will bring up the default constructor. Here we need to inject our DB context. Our DB context name is smart certified DB context, like the context. You put that and then your space, give a name. It's suggesting already, so I'm going to use the suggestion. Go here, control period, it will ask you two things. The difference between the property and field, it's just the way it is showing up here, but it is going to do the same thing. We can choose the field and brings up the field for us. Alright, so let's start here, right? So we have this kind of a name. Maybe let's change this to DB context. Okay, just to keep it simple, DB context. So we will also change this to underscore db context and just db context. Okay, I just change the name, nothing else. So let's start here. So I'm saying underscore db context dot courses. See, it is already giving me suggestion, so I can do a tab which will be the right answer. But here we can say var, okay, let's say data equal to this. So now data has a list of course, so you can then say return data. That's it, this method is done. That's why all of the error is gone. So data is nothing but list of course. List of course is nothing but IEnumerable of course, so you can also say list. Okay, so now this is called synchronous method. See, or synchronous method. This means if somebody is calling this until this is executed, this is going to wait. Okay, now let's understand the beautiful thing of the asynchronous method. Okay, so whatever we wrote is all synchronous, right? So let's not write any more synchronous code. Let's convert everything into asynchronous code. So what if I have to write this in a asynchronous way? So for asynchronous writing, all what you have to do is you have to wrap the return type. You have to wrap the return type into a task. So task of the IEnumerable of course, and you see this, it converted everything by itself. So basically until here it's the method name, and for every single asynchronous call as per the standard, the end of the method name should end with async, so that anyone who invokes it, you will know that it is an asynchronous call. Okay, so now let's go inside this and see how let's see how this will be implemented here. So for example, here again, control period, let interface is implemented, but it's not done here, right? So it's very easy. So here if you look at this, db context dot, so db context dot courses dot, and if you look at this after dot, right, everything that ends with async is asynchronous method. So for example, if there's a add synchronous method, add async will be there. Okay, so every single synchronous method will also have asynchronous method. So in our case we have toList, right? So we will have toList async as well. Okay, so all what you have to do is you have to do like this. But the reason why it is currently showing error is here it is enumerable, which means it's a readable content. Here it is iList. Okay, so that's why it is showing. So now what we can do is we can do a couple of things here. Either change this into list, you can change this into list, error went. Okay, you can do that, or you can keep this as enumerable. All what you have to do is you have to add async keyword and await keyword. So what is async await? Basically async await are used to handle the asynchronous programming. They make it easier to work with task and asynchronous operation in a non-blocking and readable manner. Alright, so that's what the async and await keywords are used. So in short, right, I can give you a small hint here so that it's easy to understand. If you look at this, I'm going to paste a few concepts here. So basically async means it will mark the method as asynchronous, okay, which we did, and then it allows the use of the await keyword inside the method. And see, the return type should be marked as task, which is equivalent of void, and task of t, which is nothing but return type. In our case the return type is this. Okay, and then for await, it basically awaits the asynchronous task to complete, pause the execution of the method until await task finishes without blocking the main thread. This is what the main concept of async await. Alright, so now we know how to do it. We don't want the synchronous method to be there, so I'm going to go there and remove the synchronous method. Okay, remember, if you have the list here, if you have a list here, you don't need to do a async await. You can just return as task, and whoever is expecting it to so you just need to await always when the data is required. At this point the data is not required, but because we have IEnumerable, we have written like this. But basically you can also say list, and you can remove this. You can go here, you can mark this as list. Okay, So this way everything is good. Okay, so now what I'm going to do is, so you know the concept of one thing, so let's quickly do the rest of the things so I can explain you. Okay, so I'm going to copy paste a bunch of methods. So basically in this case, if you see, again this is a get goes by id async. Okay, the method name ends with async. What it is returning, it is returning just one course. If the id is not present, it could return null. So that's why task of course, that could be a null. So if you put a question mark, it means that this return type can also be a null. Similarly, we have some method which checks the duplicate title. It accepts the title, it returns it's a true or false. Okay, so everything is asynchronous method. Similarly, we have add course, update course, delete course, and update description. So the input is course, return type is nothing. Okay, so we're going to implement this. So what we are going to do, we're going to do this. Everything is pulled but nothing is implemented. Okay, so what we can do, let's go one by one. Let's go to the get here. Okay, so let's implement this get goes by id. So what you have to do is, we need to access the dbcontext.goes.find async. See, there is a method called find and find async. We are going to use the asynchronous method and you just need to pass the key. So how this find async works is, for this table, okay, the primary key, so the one that you're passing, it will look for the primary key, and if it finds, it will return. So that's it. You just need to mark async and await before this. So similarly, we're going to implement for everything. And for this course async, this is very simple. Again, it's the same thing. So we're going to return a list of So for the course async, we're going to return a list of enumerable, like we already discussed about it. And here you go. The next one is title duplicate. So for title duplicate, again, it's a simple. So db context dot courses dot any. Any means it will match at least one condition is true or not. Any async means same thing but is a asynchronous. See, it is itself is telling, it's the intelligence is figuring out what we are trying to do. So async, and then we given a method, we are saying, hey, for the title which is inside the table, if it matches the incoming title, true or not, because it will return true or false. So now we will say return await this, and because we are putting await, we will just put async here. Async await, that's it. Okay, so these things are implemented. Now let's implement the add courses. So add course is simple. Add course, what it will do is, again, same thing, db context dot course dot add. And if you see what is inside the add, it is expecting a course entity. What we are getting, a course, so we will add it. Now entity framework will start tracking this record. Okay, it is not inserted yet. In order to insert, what we have to do is, we have to say, you see this, db context dot save async. You can say save changes also, but save changes async is asynchronous method. Okay, that's it. So we will change this as await and async. We're good. Because it's not returning anything, we just need to process it. Same thing for update. So for update, it's the same thing. Instead of add, you'll be using a method called update. So what this will do is, see, this ID, this course will have ID. So if you look at this, if you go inside, the course ID will come, right? The moment you put update and then pass this, entity framework will start tracking a particular entity of that type ID. Like say, for example, if ID is 20, it will start tracking the record 20. So when this statement is executed, okay, it knows that it has to update record 20. Okay, so that's how entity framework will track. But when we debug and run, we will show you how it works. Now similarly for delete, for delete, what will happen, you have to use remove, and the moment you put this, again, it will start tracking that it has to delete. So when this statement is executed, it will generate a delete statement, like delete SQL statement, and execute that. Okay, so add, delete, update, all of these are done. What is not done? Only this one is not done. So this one, what we are doing is simple. we will say, so we are getting a course ID and the description. We are first finding whether the course exists or not. If the course exists, fine, execute this, update the description, make the changes. But if the course is null, which means the incoming course ID does not exist, we just throw the exception as key not found exception. Okay. All right, so we implemented every single method. So now you know how the repository is implemented, how you can access the database. So I'll just recap. db context dot, if you put, all the tables will come. The tables is coming only because if you go to inside this db context, there is all this db set. These represents the table. If you delete any of these tables here, obviously the db context dot will not show up those tables and you cannot execute anything against the table. Okay, so db context, you know how it works, and this is how the repository is set up. Okay, so the next is we want the service to be implemented, which is calling this repository, right? So next is service. So what we will do, we will again create iService, go inside this application, go inside this interface. We will choose interface here. We will name this as iCourse service. Okay, so what we will do, again, we will do like this. All right, so service, right? See, this is the place where we will do the business logic. Now imagine if I try to put the same thing here. Okay, so for example, I put here like this. So let's change this as public. And if I put like this, what will happen? Even from the business logic layer, we are going to expose, we are going to return every single information to the user, which is not required because it has too many informations, right? We should never reveal our database entities directly to the user. So what is the solution? What will come here? For this, what we have to do is we have to create something called a DTO class. Okay, so let's go to application and then let's create a folder. Name it as DTOs. So inside DTO, what I'm going to do is I'm going to create a class called, let's create course DTO. Okay, so here what we will do, we will expose only what is required at this point of time. What we wanted to send only three information. Those three informations are course ID, title, description. We don't want to send anything else. So which means I'll copy this, I'll go to service. Instead of returning course, I will return course DTO. Okay, looks good. Okay, so similarly what we will do, we will create some more extra classes. Okay, for example, I'm going to name this here. Okay, so we have a class called create course DTO where the incoming, so when you have to send some information to create a course, we need only title and description. We don't want anything else. So for update, again, we want only title and description. We don't want anything else. All right, and then there is another class called course update description DTO, meaning we will just receive only the description, and it is maximum of 500 characters and it is a required field. Okay, nothing else we want. So we created this 4 DTOs, which is only to translate from one object to another object. So this is the front facing object. The UI will face these objects because the UI should never know what is behind the scene, like what tables we have, what interface, like what kind of columns we have. We don't need to expose it. Now given this situation, what we will do, we will go to our course interfaces, like the course services, and we're going to bring in some methods. So what we have got, again, these methods are supporting to call the database services. So get all course, get course by ID, its title duplicate, add course, update course, delete course, same thing. The only difference is the return type is not course anymore. The return type is to its respective things like update, create, right, all of those things. Okay, so that's the difference. Now what we will do, we will copy this course. Now here is the important thing you should understand. Okay, now whatever we are going to implement is a business logic, which means the interface is here, okay, which is under here. We should also create a folder called services. So right click, go here, and under services we will create this service. Okay, course service. So we will say public course implement course service, control period, it brought everything. Okay, so before we implement this, what we have to do, constructor CTOR space, we need to inject I course repository and then bring in a meaningful name, control period, field. We bought, so far good. Let's put this alone as underscore. It's not mandatory, but it's okay. We can put like this. Okay, now what we will do, we can do one by one. Okay, but I will show you something important. Okay, so let's go to the first one. Okay, so get all course. Okay, so what we are going to do is we are going to use the repository and call this get all course async. Okay, because await is here, we need to put async here. Error went, but if you look at this, it is I enumerable of course, but we need to return DTO. There are two ways of doing it. Okay, one is not a good way, which I'm going to show you. For example, you can say course dot select. Okay, you can convert into course DTO like this, and then you can say dot to list. Okay, you can do this. What does it mean? Basically, you got some format, you're returning into different format. Okay, but what if so much is coming and you need to keep mapping it? Why do you want to write this code? How can we avoid this code? So I can say this, right? See return, this is good, this is exactly good, this is the same, but can I do better? Yes, there is something called AutoMapper. Okay, so here's what we need to use, something called AutoMapper. So how do you use AutoMapper? First we need to install AutoMapper. So go to this application, right click, manage NuGet package, go to browse, type AutoMapper, and you're gonna install AutoMapper. Okay, so AutoMapper got installed. Now we need to do some configuration for AutoMapper. Okay, so for that what we have to do is in the application itself, right click, let's create a configuration for AutoMapper and we will name this class as mapping profile. Okay, this is just a mapping profile, so all what you have to do is, this is just for learning, it's good to do. Okay, so public class mapping profile, and this one needs to inherit something called profile. Profile is coming from AutoMapper. The moment you do this, okay, and then what you have to do, we have to write a constructor like this, and what you have to do is you have to do this, create map source destination. Source is this, destination is this. So if this format is given, you need to convert it to this format. You have to write like this. You can also write like this. You can also write like this. Okay, this is like both the side, A to B, B to A. But to make it better, what you have done is there is something called reverse map. So the second line of code is not required. That's why this reverse map is. Now because you have put this, there's another configuration that you need to do. You have to go to this program.cs, and in the program.cs, what you do after you have this code, you need to configure this AutoMapper. Okay, you see this builder.service.add AutoMapper of type this. So add AutoMapper is giving you error because it doesn't know what is AutoMapper. So let's comment this. So what you do, you have to install the AutoMapper in this project also. So same thing, right click, go to NuGet package and go to AutoMapper, install it. After you install it, if you come here and uncomment this, the error should go. Okay, so this configuration is done. Let's go to the service. Now in the service, what you have to do is to ignore this code, we need to inject the AutoMapper here. So here right click, IMapper, we will name this as mapper field. Okay, so let's keep this as underscore mapper just to be consistent. Now what we will do is we will remove this code. Instead we can say where data is equal to mapper dot map. Okay, see, the intelligence already wrote the code for me. So basically mapper dot map, we are giving the return type, like this is what the return type is. Input is course. Now AutoMapper knows how to map it, so you can write like this, or just to simplify you can just return like this. See, in one line the AutoMapper will do all of the work. So do you know how the AutoMapper works? AutoMapper works based on property to property. As long as the course DTO and the course has same properties, the AutoMapper will be able to map to each other. If the property names are different, we need to manually map, which also will come into our series. I'll show you when that comes. Now exactly like this we're going to implement the rest of the thing. Okay, so if you look at this, I implemented everything and this is same. Okay, we are just calling the repository. For every single call we'll be using the repository. So for ID we call the repository, we get the data. Okay, if the data is null, return null. If not, mapper.map, this is my return type, this is the input, and I'm returning it. That's it. Same thing, wherever AutoMapper is not required, we don't need to use it. And for add course, pay attention, incoming is create course. We need to convert this into course. So mapper.map, I want in this format, which is the course. Input is create course DTO. It will convert into course here. Now this course is what is required in the add course async in the repository. So before we send this, we are just updating the created by and created on. Okay, remember we do not have any authentication in place, so that's why in this video when I say put one, assuming the user profile table has at least one record. When you execute, if you find errors, which means user profile table does not have any record, just insert one record in your place and use that ID. This is just until we get to the authentication part. Once we get to the Azure AD B2C authentication part, this part will be removed. User ID will be automatically injected. Okay, so don't worry about that. For now, we just keep it as one. Okay, so remaining it's all same. There is no other difference, and that's it. The service is implemented. So if you come here, Control RG will remove the unused namespaces. So let's save this. We're good here. Next part is the controller part. So let's go to the controller. We have something called course controller, right? So course controller. So go here, right click. Okay, let's delete this first. We don't need this. Right click, controller. We're gonna choose API, empty controller, nameless. That's it. Okay, so here what we will do, we will need to implement. So this is the place where all the endpoints will come into picture. Okay, so same thing again, CTOR, inject the constructor, and we will inject the required services. I course service, not the repository. We should never touch the repository. Okay, so we will add this as service. Okay, so we'll name this as like this, just renaming it. Now let's involve the first one. Okay, the very first one is the get endpoint. So we will say public async ask of I action result. Okay, this async and task is coming only because it's an asynchronous method. That's why this 2 is coming, but basically public I action result is the return type, and then we name it as get all course. See, it is doing every code for us. So it's getting the course by service dot get all async, returning an OK object. If you hover this OK object, right, it will say it is going to return a 200 OK. If you remember, for the get calls, generally it can return only 200 OK, okay, unless it's something goes wrong. Okay, now is this done? No. Basically, what we have to do is we will have to mark this method as http get. So you need to mark the method as the get endpoint. That's why we say http get. Okay. Okay. So now what we will do, there's some more thing is pending. If you remember, we added two services, right? Two interfaces. We need to provide that in the dependency injection. So come to program.cs and come to the place where we will configure the services. So this is the place we configure the services. So we will say here builder dot services dot add scoped. See, it is giving me all the hint. Okay, so let's first bring this namespace and then builder dot services dot add goes. Okay, so it's giving us all the thing that we have to do it. All right, so these two is configured, everything is looking good. So if you run this, okay, so it's running and we will come and say swagger. Okay, all right, so we are able to see the endpoint and look at this, it's so bland, right? There is nothing, it just says it's going to return 200. It doesn't say what it is returning unless you execute this, right? You have no idea what it is doing. Okay, and not only that, it is giving us some issue on the cross issue. So cross origin resource sharing. Okay, so it's not working because it thinks that it's two different site and you cannot execute. So we will fix this. So let's go to the program.cs in order to fix that. Okay, so here in the services, what we will do, we will say builder.service.add cards, and we are saying a policy name is default. We are saying policy.allow any origin, so anyone can call with any header with any method. But see, I have also given a note that this is not supposed to be like this. It cannot be allow origin any in the production. Okay, because anyone should not be able to call, only your application should be calling. So we need to configure that specific things, like which port, like which URL can call, those kind of things. So after you do this, there's one more thing. You need to apply this in the middleware also. Okay, so what we are going to do is middleware. So after this build, we will say app.use cars and we provide the policy name. The policy name is default, it's matching. Let's rerun this. So it's coming here. Let's go here. Okay, so let's run this. Okay, so it executed, it returned. We have only one record, so it's returning this record, right? But what if all of these things show something beautiful? Okay, meaning like what it is going to return, all of those information. So let's go here, and what we will do is we have something called attribute notation. So what we are going to do is we are going to go and copy paste a few pieces of code. So it says it's basically marking what it is returning. It is saying it will return enumerable of goes DTO. Return status code expected is 200. It can also return 500. It can also return 401, 403, because if there is no authentication for this, it can return all of those things. That's what it means. So if I just rerun this, now you look at this, it's showing more information, right? So it's showing it could be a 200, but if it is 200, it will be an array of this. It could be a 401, it could be a forbidden 403, or it could also be a 500. Now this looks a little better, correct? Great. So similarly, we're going to implement all the rest of the endpoints here. Okay, so I'm going to replace a piece of code here and then I will explain you because it's easy. Okay, so let's go one by one. Okay, so let's go one by one. So the first one that we saw was get courses, right? It's returning this. This we know. Good. Now the second one is get course by ID. So here what you have to do is you have to mark http get and then you have to specify an ID. This name should match here. So if I expand this, what basically it is doing is the route will match this two, and then when you call this method, you pass this ID. If the return answer is null, return a 404 which is not found. If not, we will return 200 OK. Okay, so that's why here we also say it could be a 404 or it could be 200 OK. Now for HTTP post, which means you're saving some information, so we will name this as create course. It's accepting course, create course DTO as input, and remember this one you have to mark this as from body, because for HTTP post it will always send in the body, the request will be in the body, okay, which you're going to see. And then it is going to return this status code. It is an HTTP post, and that's it. It's just going to call this method, and then it is going to return the value of the course. Okay, now update, same thing. It is expecting an ID as well as the update course DTO coming from the body. You have to mark this as HTTP put with the ID, calling the service method, returning no content. No content means 204. Basically you sent a request, we updated it, there's nothing else to do. We're saying okay, you're done, processing is done. For delete, same thing. We accepted it, we deleted it, we are acknowledging it that it's done. You have to mark this as HTTP delete. For HTTP patch, you have to mark this as HTTP patch, and if you expand this, it is coming from the route and one body. Body will be course update description, which will have only description, and you call the respective method, send no content. That's it. Now let's run this. I'm going to bring this here, Swagger, and you can see all the endpoints are here. Okay, so let's say I'm going to create a new course. So I'm going to copy paste a course which has a title and description and hit execute. Okay, so this error was thrown because the mapper that we used was not created yet. Okay, because we are just saying what to what map, but what we missed is we did not finish the mapping here. So let's go to mapping, and after this we will put two things. Okay, so what we are doing, create map. If this is incoming, convert into this. If this is incoming, convert into this. But at this point of time, we are saying for all members, there's a condition. Okay, if the incoming member doesn't have like source member, wherever it is not null, only those you map. For example, here we have these much, right? But if you go here, we have only these two. So it will ignore all the other properties. Okay, so now let's run this one more time. So I'm going to click on this create. Okay, so let's open this, go here, let's try this out. I just restarted, execute. Okay, so we executed, we got the response. Okay, now let's try one more. We got the response. Let's go here, let's try. We should get 3. We got 3, right? And similarly, if I wanted to update this, okay, so I copied this, I go to, okay, so you can specify with ID also. So 5, so we have 404, because what is the result that we got? 9, 10. Okay, so let's go here, we will say 10, hit, you got 10 result. Okay, so I'm going to copy this and I'm gonna do an update. Okay, so let's go here, update. So we have to specify that it is a 10. Copy paste here. I'm saying, let's say I'm removing this. Okay, and updating this. Got updated, got 204. If you go here, execute one more time, the third one got updated. 10 got updated. See, I deleted this. Looks good. Okay, so far good. Patch, again same thing. If I say 10, and if I just specify description as like this, it's updated. If I go here, hit again, I got my response back with the updated information. Okay, now what we will do, last one, we're going to test this. let's say 10 got deleted. If I go here, 9 and 10 got deleted, 11 is there. Okay, here's the important thing I'm going to show you. If I copy this, okay, there is some problem with this which I will show you in the upcoming so there's a problem which we are going to resolve it, but let me first show you the problem. So if you come here and try to accidentally create the same thing, for example, same one, execute, it executed again. What is the problem? I'm creating the same thing again and again, right? That's wrong. It is supposed to be unique. I don't want to repeat this. So here comes the Fluent Validation. So with the help of Fluent Validation, we can pre-check the conditions, and only if conditions are valid, we will proceed. If not, we will not proceed. So come, let's learn the Fluent Validation next. So now let's see how Fluent Validation is going to help us with the scenario that I just explained. So we're going to do the pre-validation. So first we have to install the Fluent Validation for ASP.NET Core. So I already have the package. So let's go to this project. Okay, so like I said several times, you can either put the package reference directly here, because I know the package reference I have put here, but if not, you can just use this package name, go to the NuGet package and go to the browse. If you enter this, it is going to show you the latest one, which is 11.3.0. but at the point of you watching the video, it could be a different version, but it's up to you. You can use the one which is in the project, or you can use the latest one. So do an installation, and that installation is going to anyway bring this one here. Now similarly, we want a few more things to be added. I'm going to quickly add to save some time. So this is Fluent Validation for ASP.NET Core. We need for dependency injection and the regular Fluent Validation. So these three packages we want. Okay, so now we have this packages added. In order to install, we just need to build it. So Control-Shift-B is a shortcut for building. If you go here also, it will be the same thing, Control-Shift-B. So I'm building the project, and it is going to restore the NuGet packages, and everything should be good. Now what we will do, we will add a couple of important code that is as per the documentation from the Fluent Validation. So don't think that I'm doing something special. So it's nothing special. So let's open up this project. Here is the place where we are going to put the Fluent Validation. So right click on here, go to add, create a folder, and we will name this as filter. So why do we do this? As per the clean architecture, all of these filters should come at the API layer, and that's why we're adding a folder here. And I'm going to quickly create a file called, not the controller. So right click, add item. So a class that's named validation filter, and I'm going to quickly copy paste the validation filter here. This is as per their thing. See, after I added, all this required namespaces got added automatically. So we want this because this is the pipeline for the validation filter to go through, and then it generates the error. It generates with the property name and the error message, and that is what we get eventually in the 400 BAT request. So you can debug this and see it's nothing special. It's just gonna execute this and see what else we have errors, and it's gonna propagate the error to the UI. Now let's save this. So now what we do, let's open up this application layer, right click, create a folder where we will put all of those validations. So we will name it as DTO validations, and the first thing that we are going to validate is the course validator, because we saw the course is duplicating, right? We want this title to be unique. If the title is already exists, which means let's not create the same course again. So I'm going to create a public class, this one, and here is the thing. So you need to actually inherit abstract validator of type this DTO. This is nothing but the, if you open up this controller, if you wonder what is this, see under HTTP post, this is what the input model is. So we are validating this. That's why it is written like this. Now I think we need to install, because we're using the Fluent Validation, we need to install the Fluent Validation package here. So let's go to this application layer, come here, put this, let's go here, let's comment for a second, build it, uncomment, Control K, you will uncomment, Control A will select everything, control A will select everything, and then followed by control K, control C will comment everything, and I just uncommented it. Now the package is installed, so let's bring up the namespace. Control period should bring up the namespace, and then in order to clean up all of this unused one, control RG. Okay, so that will clean up this unused one. Now what we have to do is, we need to write some simple logic, like for example constructor. So here's our constructor, and it just added itself, it made our life easy. So basically what we're doing is rule for that belongs to the Fluent validation. So rule for x goes for x dot title. So from where this title is coming, basically this class is inheriting abstract validator of this type, right? And if you go inside this, we have these two property. So basically x dot title is nothing but this property. See, f12 is taking us to that place. So what we are doing is, we are saying it should not be an empty and its maximum length is 50, but logically speaking this is not 50, it just auto generated code, right? So it's basically 100 characters. And similarly for description, we are saying 500 characters is the max length, and maybe this also should not be empty. Okay, so the moment you put dot, all of the Fluent validations inbuilt extension methods will come. You can do so many stuff here. Now what we can also do is, we can also see not empty, not null. We can check all of this condition. So maximum length we have put, and then if everything is like one or more things is not passing, then we can actually send with a message, like with message we can send a custom message. Okay, so stay here, and for this one again, not empty, not null. Okay, so far good. But what is our idea? Our idea is to check the input title is belongs to the database table. So what we can do is, from here we can access the repository, because so let's say for example I goes repository, I'm injecting the repository through dependency injection. Control period, it's going to bring up this one. So what we are doing here is, after this, right, after this we are saying dot must async. So must means synchronous, must async means asynchronous. We always wanted to write asynchronous code. We are opening, we are saying async, that goes for title comma cancellation. All right, so now given these two parameters, we are saying do the following. We are saying check repository, course repository dot is title duplicate async, and we pass the title. Okay, so because this is asynchronous, we need to do a await. Okay, but also we have to return that this is wrong only if it is not. For example, if the title do present, so let's say for example, let's quickly fix this. So basically we are saying course repository dot is title. So we are passing the title. If the title is unique, okay, what will happen? I mean, if the title is having duplicate, if it returns true, then we should also stop. We should succeed this call only if it is false, meaning like there is no duplicate, so we're good. So that is what we have done. Now is this enough? No, not really. One thing with the Fluent validation is, because this is using asynchronous call, we cannot inject this in the pipeline to make this Fluent validation to run as per the pipeline, meaning we cannot make this to invoke by itself. That's what I meant. All right, so what we have to do further is, we need to go to this program.cs. okay, all what you have to do is, let's go to the add controller method here. Okay, we are going to do few things. So first thing is, in the add controller we are injecting a filter. So anything that goes inside a controller will go inside this validation filter, which is nothing but our Fluent validation filter, which is written here. Now after that, that's it. So after this, what we have to do, this code, right? This code is nothing but, we are intentionally suppressing the automatic validation so that we can validate our model through the Fluent validation. All right, so we really don't need this, but it's better to have it. So after this configuration, now after this validation, what we will do, let's go to this course controller, which is here. Okay, so we need to inject a validator. So what we are going to inject is, we are going to inject something in the constructor. So here we go, constructor comma, we inject I validator of this one, and what we will do, we will control period, we will assign a field. We got the field, right? Now with this one, let's go to this http post here, and what we are doing is, let's go to http post. Okay, here we are going to manually do this validation. See, the code is already telling me what to do, so I'm going to paste a piece of code. So basically we're saying this validator dot validate, pass this, and then once we get the result, if the result is not valid, we return a bad request with the errors. Okay, so I'm going to save this, I'm going to run this. If something breaks or something doesn't work, it's okay. I will show you how to fix it. So let me bring up this, right click, Swagger. So let's open up this, let's bring what we have it in database. Okay, so we are saying it is giving us some error, it's not able to resolve something, correct? So what did we miss? So probably we missed to hook up something. So let's go to this program.cs. okay, so if you face this kind of an error, so come to this program.cs. let's go just right below this, maybe here, anywhere you can write. So we are just hooking up builder.service and validation from the assembly, and we are saying this is the one which needs to be kicked in. Okay, so now let's save this, applying code change. Okay, so now let's run. All right, it didn't work only because it did not apply the code change, so we need to just restart the application. So after I restart it, if I execute, it's coming. So what we are going to test is, we will do one thing. So we have 9, 11, 12, 13, right? So 9, so 12 and 13 is duplicate. So what I'm going to do is, I'm going to copy this, okay, and let's go to 12 and 13. Let's delete 12 and 13. Let's come here and execute. See, we have only one. So if I try to insert the same thing, it should stop us. So let's try this out, copy paste, it's the same thing. So I'm going to try this, so if I go and just take a breakpoint here, so so I'm going to hit this. See, the Fluent validation has kicked in, it has returned the value, and we got error, the course title must be unique. See, now we are preventing users by accident also. We are not putting any wrong data into our system, right? So that's how the Fluent validation works. So similarly, what we are going to do is, we're going to do for the update also. So I added update course validator. Again, that's abstract validation of this update course DTO. Same thing, we are checking the title, we are checking the description, and also we're checking title should not be duplicate. I'll tell you why we need this, okay? And then once you add this, let's go to the course controller. Again, same thing, I injected one for the update, put this here, come all the way through the update statement, I added this. This is exactly same how we did this. It's just a matter of what you pass, okay, and use the correct validator. Now here is the scenario. Okay, so what I'm trying to do is, if you look at this, it has two courses, right? So this course title is EF core. Now I will take this EF core and I will try to update this EF core into D9, which means this will become duplicate. It should stop us. That is our test case. So let's go here. Let's take this 9 and I'm saying update this 9's title into EF core. It should stop. It stopped because this course title must be unique. It's already there. Correct? Okay. So for example, title you pass does exist. So, this makes sense. So basically we're going to do the same thing. You will see the difference, what's happening. Okay, so we already know. So let's go to this one and let's try this out. I'm saying, hey, update 9 like this. So if I execute, it's checking and it's saying the course title must be unique. The title you passed does exist. See? So this way, the UI can change it. So this is how we need to protect our backend. Doesn't matter you put validation in the front end or not. No matter what, backend is always should be double checked with what is coming, so that data integrity is maintained and no messy data is inserted into. Because if you miss something and it screws up in the data, there will be a bigger problem in company to resolve that data. So it's better to have a solid concrete validation in the backend, so we prevent all of this bad data coming into the picture. Okay, so now we are protected. Similarly, we will be doing a lot of other stuff where a lot of validations and things will come. Now exactly what we did, right? Like that, I have added the quotients and the choice controller. Okay, it's already there. This is exactly same as what you saw in the course controller. So we have ordered the choice, we have added the quotients, and if you look at this further, here also we have some quotient validator which checks a couple of things, all of these difficulty levels and all of those things. We have choice validator which checks the choice are correct, right? So I've added everything. So it has its own repository, quotient repository, choice repository, and then it has its own services. You see this choice services, quotient services, they're all like almost same thing. We don't need to repeat the same thing again and again in this video recording. We don't need to repeat this again and again, because I wanted you to take a look and try by yourself. Now after you verify these 3 controllers and you're solid, all what you do is you come to this missing implementation. This is intentionally kept it only for you guys. So I have already given what is missing. For the quotients and choices controller, we need to check the incoming model quotient ID do present, choice IDs do present in the database or not. According to that, we need to return the data back. So similarly, missing pieces are returned here. Okay, we need to add the response API. So for example, if you look at this choice course controller, we added these things, right? These are not present in the choice controller and quotients controller, right? So these things you're going to add it so that you will learn it. Now after you do all of this homework, you can name it as homework or whatever it is, but basically if you do all of these things, you'll learn very good. Now that concludes our current video. This concludes our current video episode. So in this video we saw so many things. We saw how properly write a code from starting of the API till the repository, where the interfaces will go, where the services will go, why services will go here, why repositories will go here, and we also saw how Fluent Validations comes into picture and all of those things. So take a look at the code there and start doing all of these things by yourself. You'll have wonderful learning with .NET Core and robust coding and great standards that a company follows. Alright, so don't forget to follow me in GitHub. All what you have to do is go to my GitHub account, and we have a lot of my users following me. So come here and click on the following, and so you will be added to the following list. Alright, so that you will know first as soon as the code is checked in. Okay, so the code is going to be here. If you go to this repository, you'll see this Angular code, .NET Core, everything is going to be here. So stay tuned, keep learning. If you have any questions, don't hesitate to contact me. Put your questions in the comment section. In less than 24 hours, you will be expecting in less than 24 hours, most likely I will answer your question. Right? So stay tuned, and I hope you enjoy this video. If you like this video, don't forget to subscribe and don't forget to hit that like button. Don't forget to subscribe and share this with your friends. Let's build a unique, robust application in 2025 that's going to rock your career. Right? Stay tuned, and I'll see you in the next video, guys. Bye-bye. Thanks for watching. If you found this video helpful, please give it a thumbs up and subscribe to our channel for more tech tutorials. And don't forget to hit the bell icon to get notified when we post new videos. If you have any questions or suggestions, leave them in the comments below. Happy coding!